this video, let us see about the classification of elements based on electronic configuration. In the modern periodic table or the long form of the periodic table, you know that the elements are classified as 7 periods and 18 columns. And in order to make it more easier for us to understand and for us to remember, this was given, that is the classification of elements based on the electronic configuration. So we have to see the outermost electrons, that is the electrons present in the valence orbitals, and those are that electrons that are filled will make the group. Okay, so depending upon this one, depending upon the electronic configuration, there is a classification, and that is called the long form of the periodic table has been divided into 4 blocks, that is S block, P block, D block and F block elements. You know, S block elements, this come under at the extreme left of the periodic table, and P block elements come to the right of the periodic table, and the D block elements are present at the center, and the F block elements are present at the bottom most of the periodic table. Now we'll see what is S block elements, P block elements, D block and F block. See, first one, S block. See, what is this S block elements? There are 14 elements, and they are the 1A group metals and 2A group metals. So they are alkali metals and alkaline earth metals, and here their electronic configuration, the outermost shell electronic configuration is NS, either it will be 1 or 2. So it will be 1s1 or 2s1, 3s1, 4s1, like that it goes on, and so that the value of N ranges from 1 to 7. So you can see this is the periodic table, that is the S block elements. Here is one more S block element that is helium, that is present along with the P block, but it has to be under the S block because it is helium 1s2. Okay, and these are all completely electropositive substances, and they are all metals, but helium will come under inert gases, so it is placed in the periodic table under P block elements. Okay, now we'll move to P block elements. See this one, now we can show this S block elements. It is 1s, 2s, 3s, 4s, 5s and 6s and 7s. So these are all S block elements, and see here this is one S block element. Okay, now we'll move to the next one, P block elements. P block elements are those in which the last electron enters into one of the 3 p orbitals, that is which is being filled. Okay, here the p orbitals are being filled, and so they see the electronic configuration of the P block elements. It starts from, that is it will be, that is NS2 and NP 1 to 6 electrons, either one it is NP1 or NP2, NP3, like that it goes on. Here the value of N ranges from 2 to 7. See, these are the P block elements, and these P block elements, what is the speciality is, here there are fewer metals and majority metalloids and the rest non-metals. So they have a mixed characters, that is metals, metalloids and non-metals, all are present under the P block elements. This next point, important point, this S block elements and P block elements, they are togetherly called as representative elements. You can see this one, S block, P block, S block elements, and this P block elements, they are called as representative elements. They are also called as normal elements. Okay, next we will move to D block elements. Here the elements in which the last electron enters into any one of the 5 d orbitals of their respective penultimate shells. So what is the meaning? Penultimate shell means the shell that is it is the shell before the last one. Okay, that is called penultimate, that is it is in before the ultimate shell, that the last shell. So that is, see the electronic configuration, it is n minus 1 d to the power 1 to 10. So from D1, so D1 to D10 electrons are being filled, and here the NS will be equal to 0 to 2. So here the shell that is being filled is the penultimate shell. Okay, and so these are called D block elements. Here the value of N ranges from 4 to 7. You can see here it is, see this one, it will be 3D series because the last orbit will be nth, that is the 4th orbit, but the electrons are being filled in the third shell. that is, so that it comes under 3D series, and this is called the 4D series, and this is the 5D, and this is the 6D series. See this D block elements, and here it starts, these D block elements, they are also called as transition elements. Why the word transition is because, see, because they have incompletely filled d orbitals in their ground state. So what happens, there may be that readily electronic excitation takes place, and so the electrons may shift from the lower d levels to the higher d levels, so that dd transition will take place, and so the compounds formed because of these elements are colored in nature. And so these are called, they saw the name the transition elements. And here there are 3 series. Okay, the first series will be studying mainly in these compounds. They form readily coordination complexes, and so under coordination chemistry you will be studying all these D block elements, and it is placed in the center of the periodic table. And here that is the groups, that is it will be 3b, 4b, 5b, 6b, 7b, and the 8th groups, and then 1b and 2b. All these columns will come under transition elements. Okay, now we'll move to the last one, that is the F block elements. Elements in which the last electron enters to any one of the 7 f orbitals of their respective anti-penultimate shells. So what is the meaning is, that is ultimate and then penultimate, that is before that, and the anti-penultimate is before that. Okay, so it is n minus 2. That shell is being filled, and there in that shell the f orbitals are being filled. So here the n value of n ranges from 6 to 7, and see the electronic configuration, it is n minus 2 f0 to 14, and n minus 1 d0 to 2, and ns2. And here this cannot be placed in this position. See, this is the position of this F block elements, that is lanthanum series and the actinide series, but they cannot be placed along with the D block elements. So they have placed it, so it has been placed separately in the long form of the periodic table, and that here f orbitals are being filled. Okay, and so these are called F block elements. Here they are also called as inner transition elements, because they are inside the transition, within the transition elements they are present, so they are called as inner transition elements. And see the series, that the first series, this is the first series, and that series that will come under the 6th row, but it cannot be placed, since it cannot be placed there, 57 to 71 they are placed as separate in separate position, and that will be the 4F series, and that is called lanthanide series. Okay, and next will be the actinide series, and that is the 5F series, and so it is actinide. It must be placed in the 7th row, but as there is no possibility for that, here it has been placed as a separate row, and that is F block element, actinide series and lanthanide series. This actinide series, the elements that are present after uranium, they are all called as uranium series, transuranic elements, and they are all artificial elements, and that will come under actinide series. And so the periodic tables, we can see the periodic table, the classification as, that is S block elements, P block elements, they are all metals and metalloids, and non-metals, particularly non-metals come under P block elements, and then the D block elements, they are all transition elements, and they are also metals, purely metals. And then F block elements, they are almost radioactive elements. This lanthanide series and actinide series, they are all majority are radioactive substances, and they are kept separately in the periodic table. So this way, this makes us learn the periodic table in a very easier way, so that we can understand the positions of metals, and then the non-metals, and the metalloids, and the transition elements, and the lactanides and the actinides. Okay, thank you.